Hi, and welcome to this video on tangent lines. Today we're going to explore what can happen when a circle and a line meet, and we'll start by exploring how these two shapes can interact. The most a line can intersect with a circle is by crossing over it like this. We can see that the line intersects the outside of the circle at 2 points and creates a line segment between those 2 points that is called a chord. A line that cuts across a circle in this way is called a secant to the circle. Another scenario would be a line that doesn't intersect the circle at all, like this. Even though the arrows on the line represent the line going on forever, it will never intersect with the circle. There really isn't much to say about this one, but we should be aware that it can happen. There's one other thing that can happen with a circle and a line, and it looks like this. In this case, the line only touches the circle at 1 point. This line can be described as a tangent to the circle or tangential. The point where the line and the circle touch is called the point of tangency. Looking closely at our diagram, we can see a radius of the circle meeting our tangential line at a 90-degree angle. For our line to be truly tangent, this must be true. If our line isn't exactly perpendicular to the radius at the point of tangency, it will actually touch the circle twice, though possibly very close together. We can see that with a close-up that shows the angles just a few degrees away from 90 degrees. Even if the angle were even closer to 90 degrees, such as 90.1 degrees and 89.9 degrees, this would still happen, though it would be harder to show in a diagram, at least without a microscope. Now, what if we're given a circle with a tangent line and we want to know the slope of the line? If we know the center of the circle and point of tangency, then we can figure it out. Let's take a look. We can see that the center of the circle is at the origin, or the point 0, 0, and the point of tangency is at -3, -5. Since we have 2 points on the radius, we can determine the slope of the radius using the slope formula. Let's call the center of the circle point 1 and the tangency point number 2. Remember, it doesn't matter which point we call 1 or 2, just that we need to be consistent on how we substitute once we decide. So this is going to be our x1, y1, and our x2, y2. M equals y2 minus y1 over x2 minus x1. Which gives us -5 over -3, which is equal to 5 over 3. So we found the slope of the radius, but that's not the final answer because we're trying to find the slope of the tangent line. Since the tangent line is perpendicular to the radius, we can find it by taking the negative reciprocal of the slope of the radius. Finding the negative reciprocal just means that we flip it over and change the sign. So the slope of the tangent line is -3 over 5. That's all there is to it. Thanks for watching and happy studying.